أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. The Rician fading model, named after Logi Rician, extends the Rayleigh fading model by considering the presence of a dominant line of sight component in addition to the randomly scattered multipath component. This model is particularly relevant in scenarios where there is a clear line of sight observed between the transmitter and receiver, such as in outdoor environment or when there is a minimal obstruction. In this unit, we will firstly introduce the Rayleigh model, and then we discuss and interpret the Rayleigh fading model. Pricing fading model is basically inherently stochastic model, which means that rate of propagation is it randomly distributed as a function of the time, and it is caused by the mostly with the multipath interferences when the receiver receives many signals and some signals are distributed, stochastically distributed with respect to time, delay, phase, amplitude. But at least one of the paths is changing, in other words. Rising fading occurs when one of the paths, typically a line of sight or some strong reflection, is much stronger than the other received signal. The rising fading, the amplitude gain is characterized by the rising probability distribution, and rarely fading is sometimes considered as a special case of the rising fading when there is no line of sight signal, no any strong signal. In such case, the rising distribution will describe the amplitude gain in rising fading reduced to the Rayleigh distribution. And rising fading itself is a special case of two-wave with a diffuse power fading. The mechanism of the rising fading involves the reception of signal that is composed of two distinct components. One is a line of sight component. This component is specially denoted the unobstructed signal route between the transmitter and receiver without any instances of scattering and reflection. And other is multipath components are generated when the transmitted signal reflect, or is scattered of subject in the surrounding environment. The probability density function of the Rayleigh fading model offers understanding of the distribution of the amplitude of the received signal um, in the fading channel that has a dominant line of sight component and a scattered multipath component. Now we will analyze the element of the Rayleigh probability density function equation as fx is equal to 2k plus 1 divided by k e power minus k plus 1 x squared divided by k sigma squared I naught, which is the Bessel function of 2k k plus 1 x square over sigma square in the under root. So actually this equation involves many parameters where x represents the amplitude of the received signal and k is the Rayleigh factor, represents the ratio of the power of the line of sight component, and sigma square is the variance of the received signal envelope. And I naught is the model a modified Bessel function of the first kind of order zero. Here you will see that Rayleigh model contains three factors: a scaling factor, decaying factor, and a Bessel factor. We will try to discuss each of these factors in little detail for comprehensive understanding of the Rayleigh probability density function. Now let's interpret each component. First one is the scaling factor, 2k plus 1 divided by k. This term denotes the factor by which the entire probability density function is scaled. The presence of a line of sight component influences the overall shape of the distribution. As the value of k increases, with significantly a greater presence of the line of sight component compared to the multipath component, then this term grows in magnitude, hence affecting the form of the probability density function. And similarly, when k is decreased, the magnitude of the envelope is also decreased for probability density function. Exponent term of Rician PDF given the rate of the probability density function and will decrease. Then the phenomena being described is also known as fading, which is characterized by the gradual decline in the signal power as the distance or the value of x increases, following an exponential pattern. So the quantity minus k plus 1 x squared divided by k sigma squared represents the rate at which the decay occurs. So higher value of k lead to slower decay because of the stronger line of sight. And term includes the modified Bessel function, and it illustrates the impact of multipath fading on the probability density function. The Bessel function accounts for the fluctuation in the received signal caused by the arrival of the scattered waves from various directions, thereby capturing the impact of multipath interference. This Bessel function also depends on the k. As the value of k increases, suggesting a higher line of sight component, the impact of this term decreases, emphasizing the dominant of the line of sight component in the fading channel.